Welcome to MSBT online learning platform. We bring you the most relevant content in an exciting digital format. Today, we will be studying a very interesting module from Applied Mechanics, which includes analytical method for resolution and composition of forces, where we will be studying some interesting facts about analytical method for resolution and composition of forces, and we will be practicing some of the examples based on it. So let us begin. Dear students, today we are going to learn module from Applied Mechanics subject, out of which the topic is analytical method for resolution and composition of forces. In this topic, the objectives are to determine resultant force of coplanar force system by analytical method. There are two different methods. Initially, in this part 1, we are going to see analytical method. Then in this topic, there are different learning outcomes are there. At the end of this module, we will be able to learn the procedure to find the resultant of given coplanar force system using law of parallelogram of forces and triangle law of forces. Then we will be able to resolve the given single force into two orthogonal components. There are other components are there which are called as oblique components. Then third objective is calculate the resultant of the given coplanar force system by analytical method. Students, the Applied Mechanics subject is very much useful in every walk of our life. Whenever we go outside, everywhere we come across use of this Applied Mechanics subject or knowledge of this subject. The examples are like this, that while lifting any object, we apply the force and we try to lift the object. Then another example may be balancing of our weight. Then we can have another example, that is during walking, we apply the forces. So those all come under Applied Mechanics subject. Then another examples can be stated as prevention of any block which is on inclined plane. We have to apply the force to prevent it from moving down the plane. Then other example, resultant force acting on arrow required for its driving through the bow. Then we can use this for lifting of any container in a particular direction by the application of forces by different men in different directions. So now we can have more understanding about this resolution and composition of forces by having one graphical example where we can have the image of one sailboat is there, how it moves. So it moves with the direction of wind. Here the wind direction is acting in this particular direction, and on this sailboat different forces will act because of this. These forces are, one is sail force which is acting like this, another is force of water on keel. This force acts below the water level, and these two forces have got vertical component, they balance each other, and the other components which are in horizontal direction, they both add together and becomes their resultant sum of all forward forces, and because of this the sailboat moves in that direction. This is the one of the best example that we can understand the meaning of resolution and composition, or how it is helpful in your day-to-day life. Then initially, while learning this topic, we must know some knowledge of the previous semesters. So in previous semester, we have got different subjects: physics, mathematics and engineering graphics. From this particular subject, we need some knowledge of scalar vector quantity from physics. From mathematics, we need trigonometric function. From engineering graphics, we need the projections of lines and etc. Then this mechanics subject is helpful in higher semesters. So, in higher semester, the mechanics of structure subject is there and theory of structure subject is there. In this particular subject, we need the knowledge of resolution and composition of forces, or the subject applied mechanics. Then in third year, we have got again two subjects are there. One is design of RCC and steel structures, and another is advanced design of structures. So, these two subjects are in the 5th and 6th semester. So, in this way, we can have the link of this particular subject with the lower and higher semesters. Here, we need some previous knowledge before learning this particular topic or this subject. These learning topics or subjects are from the previous semesters, which are, one is mathematics, then we need the knowledge for physics, then engineering graphics, and at the same time, the unit number 1 from this particular subject applied mechanics, that unit is mechanics and force system. The knowledge of this unit is also required while learning this topic number 3 or unit number 3. So, while learning this, we again need some concepts, and these concepts are, one is force. So, as we know that force is a external agency which tries to change the uniform motion of the body and state of rest of the body. This force is an external agency. Then we have got force systems, as I explained earlier, that one is coplanar concurrent force system and another is coplanar non-concurrent force system. Now, first is coplanar concurrent force system. In this system, we have got different forces are there. One is F1, F2, F3, F4 and F5. All these forces are passing through this single point O. Therefore, this system is called as coplanar concurrent force system. Then second system is coplanar non-concurrent force system. In this system, we have got different forces F1, F2, F3, F4, many forces may be there, but here we see that these forces, all these forces are not meeting at single point. F1 and F4 is meeting over here, F2 and F3 is meeting over here, but all these four forces are not meeting at single point. Therefore, it is called as coplanar non-concurrent force system. Then next concept is resultant force. The resultant force is a single force which is producing the same effect as would be produced by number of forces acting on the body. This single force is called as resultant force. The resultant force may be 0 or may not be 0. If the resultant force is 0 in concurrent force system, then that body will be in equilibrium, that is at rest position. Next concept is composition of forces. The composition of forces is the procedure or process of finding out resultant force, that is single force, which represents the number of forces acting on the body. This process is called as composition of forces. The composition of forces of two force concurrent force system can be obtained by one law is there, law of parallelogram of forces. The law of parallelogram of forces is the fundamental law in applied mechanics, which demonstrates the method of composition of two force concurrent force system, and this law can be stated as resultant of two force concurrent force system is represented by a diagonal of parallelogram passing through intersection point of initial sides of parallelogram representing the vectors of these forces. This law can be stated in another way. that if two coplanar concurrent forces are there, and if we draw a line parallel to these two forces to represent a parallelogram, then diagonal of that parallelogram represents the resultant in magnitude and direction. This can be explained as in the next slide. Here we have got two forces, F1 and F2. These are concurrent forces making an angle of theta between them. Then if we draw a line parallel to F1 as a vector, this AB represents the force F1 as a vector. Then draw a line F2 passing through this point and parallel to F2 as a vector. Vector means we require scale here to draw line AB and line AD. After this, we can complete this parallelogram A, B, C and D like this, and after completing parallelogram, the line or diagonal passing through this particular point A towards C, this represents the resultant force of these two forces F1 and F2, and this resultant force R, which makes an angle of alpha with this horizontal. Now from this diagram itself, we can have the equation of resultant force. The equation for resultant force is like this: R is equal to AC, and which is equal to square root of F1 square plus F2 square plus twice F1 F2 cos theta. Then there is angle alpha is there. So another equation is there: tan alpha equal to CE divided by AE, which is equal to F2 sin theta divided by F1 plus F2 cos theta. So in this way, we can find out the magnitude of resultant force and the angle alpha from this law of parallelogram of forces. So this law of parallelogram of forces is for two concurrent forces only. Then we can have particular cases of two force system. Particular cases means whatever angle between the two forces theta, if we change that angle, we can have particular cases. Here the first case is that the angle between F1 and F2, here it is 90 degree when theta is equal to 90 degree. So in that case, that parallelogram becomes a rectangle, and in that rectangle, this again diagonal is the resultant of these two forces F1 and F2. This R is equal to square root of F1 square plus F2 square. Then next particular case is when theta is equal to 0. Theta is equal to 0. In that case, we get the forces in the same direction. They are collinear with each other, F2 and F1. So simply the resultant of these two forces will be equal to F1 plus F2. Then next case is when theta is equal to 180 degree. In that case, the direction of forces becomes opposite to each other, but they are collinear. Means F1 is going towards right side, F2 is going towards left side. Hence, here we get resultant R is equal to F1 minus F2. This can be explained from this slide also. In this slide, we have got this F1 and F2. If angle theta, if it becomes 0, then F1 and F2 will be in the same line. If theta is equal to 180 degree, then F2 will act in this direction and F1 is acting in this direction. So therefore, here in theta is equal to 180 degree, we get resultant equal to F1 minus F2, and resultant R is equal to F1 plus F2. Another law is there, which again based on to find out the resultant of two concurrent force system. This triangle law of forces is derived from the law of parallelogram of forces itself. This law can be stated as if two forces are acting at single point and if they are represented by free vectors placed one after the other, then the resultant represented by the vector directed from tail of first vector to the tip of the second vector, that is closing side of a triangle. It can be explained over here. Here we have got again two concurrent forces are there, one is P, another is Q, angle between them is theta. Then in this particular system we can draw lines as per the law of triangle of forces, that one force, that is P force, is plotted from O to A with some scale. Then we have drawn force Q from A to C, and OA and AC, these are the two vectors P and Q. And the closing side, this dotted line indicates the closing side of this particular triangle, and this closing side is a resultant force of these two forces P and Q, and resultant R is equal to P plus Q. Here vector addition is there, so we have to plot these forces to some scale and parallel to the direction of these forces. So here we can make use of triangle law of forces to find resultant of two force concurrent force system. Then next concept is resolution of forces. This process is exactly opposite to that of composition of forces. The resolution of force is the process of finding the component of given single force, and these components are two in number and they will have the same effect as would be produced by a given single force. So now if two components are there, then there is angle between these two components. Depending upon the angle between the direction of these two components, the components are classified as oblique components and orthogonal components. So initially we will learn about oblique components. So if angle between the two components is other than 90 degree, then those components are called as oblique components. So here is the single force F, and its component along this line is F1, and along this line this component is F2. So here this angle addition of alpha and beta, that is other than 90 degree. So therefore F1 and F2, these components are called as oblique components. These components again can be determined over here. Here we have to draw a single given force F as a vector, means making an angle of alpha with the horizontal. This is drawn with the scale as a vector. Then draw a line parallel to force F1 passing through this end point. Similarly, draw a line parallel to F2 through this end point. They will intersect over here, and this triangle is formed over here. In this triangle, we have got this O to A as component F1 and A to B as component F2. Here this angle is alpha as we know, then this angle becomes alpha plus beta. Now to this triangle we can apply sine rule. So by application of sine rule, the component F1 can be determined as F1 is equal to F sine beta divided by sine of alpha plus beta, and similarly F2 is equal to F sine alpha divided by sine of alpha plus beta. So these are the two oblique components F1 and F2, and this can be determined by making use of this figure and application of sine rule. Then next classification of component is orthogonal components. So orthogonal components means the angle between the two components, if it is 90 degree, then those components are called as orthogonal components. The orthogonal components are required in analysis of structure. So in every analysis, the components are orthogonal components along x and y axis. Then here that can be explained with the help of diagram. Here is the given force F, and Fx and Fy are the components of this given force F. This can be again determined with the help of that triangle law, or here what we have to do, we have to draw a line parallel to given force F as a vector, it is drawn over here. Then we have to take projection on this horizontal line, and one line is drawn parallel to this Fx, they will intersect over here. Then in that case, this line to this one, this is Fx, which is called as horizontal component of force F, and this line, vertical line, is Fy, called as vertical component of force F. So therefore denoted as Fy, and we can make use of trigonometric equations to find out the values of Fx and Fy. So here Fx is equal to F cos theta and Fy is equal to F sin theta, and as we know that these Fx and Fy should not change the effect of this given force F. So according to again trigonometric equation, we can find out the value of F, and that F is equal to square root of Fx square plus Fy square. And again it is to be noted that the theta is the angle made by given force with the horizontal x axis. This is again very much to be remembered. This is required while calculating the components in solving the different problems. Then tan theta is there, angle made by that force F with the horizontal, tan theta is equal to Fy upon Fx. Then next step in this particular topic, that is related to equation of resultant of coplanar concurrent force system. Up till now we have seen the resultant of two concurrent force system and then components of the system, that is oblique component and orthogonal component. Now we are going to have one more equation to find out resultant of coplanar concurrent force system. So here we have got the concurrent force system is there, having force F1 making an angle of theta 1 with horizontal, F2 making an angle of theta 2 with the horizontal, F3 making an angle of theta 3 with horizontal, and F4 making an angle of theta 4 with the horizontal. So this is coplanar concurrent force system. Then here are the components, just we have seen that orthogonal components. So orthogonal components of F1 in horizontal direction is F1 cos theta 1, then in vertical direction F1 sin theta 1. Similarly for F2, vertical component is F2 sin theta 2, F2 cos theta 2 is horizontal component. Then for F3, vertical component is F3 sin theta 3 and horizontal component is F3 cos theta 3. Then for force F4, vertical component is F4 sin theta 4 and horizontal component is F4 cos theta 4. So here we can again observe that in every horizontal component there is a cos of the angle, F1 cos theta 1, F2 cos theta 2, F3 cos theta 3 and F4 cos theta 4. So theta 1, theta 2, theta 3 and theta 4, all these are the angles made by those forces with the horizontal. And in vertical component we have got sin is there. So F1 sin theta 1, here F2 sin theta 2, here F3 sin theta 3 and F4 sin theta 4. So here again in vertical component we will find sin, in horizontal component we will find cos. Then resultant of this system is given by formula equation square root of summation Fx square plus summation Fy square. So now if summation Fx has got the direction in this going towards right, summation Fy has direction going towards upward side, then the resultant will act in this fashion and in the first quadrant, making an angle of theta with the horizontal. This theta can be determined by this equation, that is summation Fy divided by summation Fx. Tan theta is equal to summation Fy divided by summation Fx. Here we know that R is the resultant force of all the four forces F1, F2, F3 and F4, and theta is the angle made by resultant force R with the horizontal. The summation Fx is the algebraic sum of all the horizontal components, that is in x direction. Summation Fx is algebraic sum, means algebraic sum we have to take the different signs to be used according to the direction of the forces, and those sign conventions are to be followed in determining summation Fx. So here, if the horizontal force is going towards right, then it is to be considered as positive, and if horizontal force is going towards left, it is to be considered as negative. So accordingly, the summation Fx is determined. Here in this particular equation, this component is minus, this component is minus. So these components are going towards left and these two components are positive, therefore going towards right. This is can be seen in this particular figure, that F1 cos theta 1 and F4 cos theta 4, they were positive, and F2 cos theta 2 and F3 cos theta 3, they are going towards left, therefore they are negative. Then similarly, summation Fy is the algebraic sum of all the vertical components, that is in y direction. Again, meaning of algebraic means we have to use signs positive and negative depending upon the direction of force. So forces going upward are considered as positive in finding summation Fy. Forces going downwards are considered as negative. So accordingly, we have got the equation of summation Fy as F1 sin theta 1 plus F2 sin theta 2 minus F3 sin theta 3 minus F4 sin theta 4. So here negative sign is there, therefore these two components are in downward direction and these two components are in upward direction. So that can be seen again over here. This component F1 sin theta 1, F2 sin theta 2, they are in upward direction, therefore they are positive. Then F3 sin theta 3 and F4 sin theta 4 in downward direction, they are negative. So up till now we have seen this equation for resultant of concurrent force system. Now we will shift to the next concept or next part of this topic, that is resultant of non-concurrent force system. So the resultant procedure is same for both concurrent and non-concurrent force system. In case of concurrent force system, the resultant passes through the single point through which the all forces are passing. But in case of non-concurrent forces, that is not the case. In case of non-concurrent forces, we cannot predict the location of resultant force. Therefore, we need to have certain additional steps to be carried out in determining the or locating the position of resultant of non-concurrent forces. So this additional step required to have knowledge of some concepts, and those are again important concepts with respect to the subject of mechanics and as well as this other subject dependent on this particular subject. So the next concept is resultant of non-concurrent force system, in which concept is moment of a force. The moment of a force develops the rotational effect on the body about a point. It produces rotational effect on the body. This rotational effect may be clockwise or anti-clockwise. Because it produces rotational effect, its nature may be clockwise or anti-clockwise. So to explain this concept, we have got one graphical representation is over here. Here I have taken one example related to spanner and nut over here. Here a person is holding a spanner in his hand and applying a force in this direction, which is making an angle of 90 degree with the spanner, and because of this force, what happens? This nut gets rotational effect in this direction. So this direction of rotation is called as anti-clockwise movement. So this rotation is possible because of force which is in this direction, and this angle needs to be 90 degree, because if the force is applied in 90 degree, then we get maximum rotation about this axis, and in this case the nature is called as anti-clockwise movement, because rotation of that nut is in anti-clockwise direction. Then another figure is there. In this figure we have got, again example is of same, spanner, nut is there, then a person is applying the force in this direction, and because of this force what happens, that nut gets rotated in this direction, that is clockwise direction. Therefore whatever movement or rotational effect produced over here is called as clockwise movement. Again the angle is 90 degree. So see that every time we need the angle between this line joining this point of rotation and line of action of this force must be 90 degree. This is F is like this, the point of rotation is over here. So if I drop a perpendicular on this line of action, then this become the arm of this particular movement. So here we can explain this anti-clockwise movement and clockwise movement nature with the help of these two diagrams. Movement can be mathematically expressed as the product of magnitude of force and perpendicular distance between line of action of force and point of rotation. Being a product, the SI unit of movement is Newton mm. This product can be explained with the help of this diagram. Here force F is acting like this, and we have got three different points, point number 1, point number 2, point number 3. The point number 1 is at a distance of x1 from the line of action of force F. This is perpendicular distance. Then point 2 is at a distance of x2 from line of action of force F, and point 3 is itself passing through the force F. So therefore its distance from point force F is 0. Here we can have the understanding about movement with the help of these examples. So movement of force about point 3, that is m3. So movement m3 is equal to 0 here, because the force F is acting on the point 3 itself, or line of action of force F is passing through point 3. Therefore movement m3 is equal to 0. Then next is movement m1. m1 means movement of force F about point 1. So here the movement of force F about 1 is equal to F into x1, because F is the force and x1 is the perpendicular distance. But we can see that this F is producing the rotational effect in this direction, that is clockwise direction. Therefore nature of this movement F into x1 is clockwise. And lastly the movement m2 is there, that is movement of force F about point 2, that is equal to F into x2. So this F into x2 produces the anti-clockwise effect, that is if it is acting downward, so therefore about this point it will produce an anti-clockwise movement. So nature of this m2 movement is anti-clockwise. So in this way we have gone through these different types of movements, as well as one special case is over there, that if the point is acting on the line of action of force, then its movement is always 0. The another principle which is used for location of the resultant force in non-concurrent force system is Varignon's theorem, or also called as principle of moment. The Varignon's theorem is stated as the algebraic sum of moment of all the coplanar forces about a point is equal to moment of resultant force about the same point, and this Varignon's theorem is used for locating resultant force of non-concurrent force system. Mathematically, Varignon's theorem can be expressed as the equation summation mp is equal to R into X. So this summation MP R and X can be explained with the help of this diagram. As we know that summation MP means algebraic sum of moment of all the forces about a reference point. Here we have considered a parallel force system in which F1 force is acting downward, F2 is acting upward and F3 is acting downward. Point P is the reference point over here, and from point B the distances of F1 is x1, distance of F2 is x2 and distance of F3 is x3. Again I have shown over here R. R means resultant of all these three forces and its distance from P is x. So for location of resultant R we need the distance x. So for knowing distance x we need to find out summation MP, and summation MP is determined in this fashion, that is moment of all the forces about point P, and their algebraic sum is found over here. So F1 into x1 minus F2 into x2 plus F3 into x3. Here minus sign is taken because F2 produces anti-clockwise movement, and for this term positive sign is there, for this term positive sign is there, means movement produced by F1 about point P is clockwise and movement produced by F3 is about point P is clockwise. Okay. Then we have got R is the resultant of F1, F2, F3. So we have to substitute this value in this equation and we have to get the answer of x, and that x is the perpendicular distance of resultant R from the reference point P. So in this fashion the resultant force can be located by the use of Varignon's theorem. So students, up till now we have learned this topic. So do you have any question about the learned topic now?
Yes, sir. I have one question. What is the movement of a force?
Good question asked by you. Now I will explain it with the help of diagrammatic representation. So see here that movement can be defined or explained with the help of these two diagrams. So here a spanner and nut is there. So if I apply force in this direction, then because of this application of force, this nut moves. So movement of this nut in the circular direction, or we can call it as a rotational direction, this is called as movement. So this movement is mathematically expressed with the help of equation, that is this force multiplied by this distance, and being a rotational effect it has got nature. So its nature is anti-clockwise for this particular case, and another nature is clockwise. So clockwise movement is there. So here the force is applied in this direction, and because of this nut moves in the clockwise direction. So rotation is clockwise, therefore nature of movement over here is clockwise movement. So do you understand this?
Yes, sir. Thank you.
So students, up till now we have learned different concepts, and by learning those concepts we came to the position or situation where we can determine resultant force of coplanar force system by analytical method. So whatever concepts we have learned are types of force system, then law of parallelogram of forces, then triangle law of forces, then resolution of forces, composition of forces, then Varignon's theorem along with the concept of movement and the location of resultant. So by going through this concept we can able to determine resultant force of coplanar force system by analytical method. Now you are fully competent to solve the problem of resultant force. So here we have got worksheet is given below. So you have to solve these problems. the solutions of worksheet is provided for cross verification. Here is the example number 1 for which the solution is there. The solution is like this. So, here what we have to do? We have to determine angle made by each forces with the horizontal and show the components here. Then we have to find out summation fx and then summation fy. So, while finding summation fx, always remember that sign convention: forces acting towards right positive, forces acting towards left negative. In case of summation fy, always remember that forces acting upward positive, forces acting downward negative. Here we get the answer of summation fx as 281.20 Newton acting towards left side because it is negative. Then summation fy is equal to 334.22 Newton which is acting upward because it is positive. Then resultant is determined by using this equation. Resultant R is equal to 436.79 Newton. Its quadrant can be shown over here. Here summation fx is negative, therefore acting towards left side. Summation fy is positive, acting upward, and resultant lies in this quadrant. So, angle made by this resultant with theta can be determined by this equation. Theta is equal to tan inverse of summation fy upon summation fx, and theta comes out to be 49.92 which is equivalent to 50 degree with the horizontal. And this resultant can be shown in the space diagram also. So, here is the solution for example number 2, which consists of coplanar concurrent force system. So, here what we have to remember that sign convention is very much important part in solving these problems. Sign conventions are required for this finding out summation fx and summation fy. So, students commit mistake while taking these signs positive and negative. So, students should remember that forces going towards right side are positive, forces going towards left side are to be negative. Similarly, in case of summation fy, forces to be taken upward as positive, forces which are downward to be taken as negative. So, these are the points to be remembered because students commit mistake here and their answer is wrong in those cases if the signs are not used properly. So, by using these signs properly, we can determine the answers correctly, and this answer of summation fx comes out to be over here 55 Newton. Answer of summation fy comes out to be 641.4 Newton. Then resultant is to be determined. This is a formula. So, there is no point to be very much of importance. Only you have to remember the equation and find out the value of R. And theta is to be determined by using this equation. This is example number 3, which is on non-concurrent force system. The solution of this particular system is determined as per the process which is followed in concurrent force system. That is to determine summation fx, then summation fy, then resultant R and theta. So, all these steps are common as per the concurrent force system. Only change is that to locate the R in force system with respect to point A. So, this change is to be perfectly calculated by application of Varignone's theorem. So, Varignone's theorem mathematically expressed as this summation MA is equal to R into X. So, here we want to find out summation MA, and summation MA means algebraic sum of moment of all the forces. So, while finding out summation MA, students commit mistake in considering this sign convention. So, this sign convention is to be followed perfectly. That is, clockwise movement is to be taken as positive, anti-clockwise movement is to be taken as negative. So, here in this problem, so movement of all the forces with respect to A is clockwise. Therefore, every term has got positive sign. So, no negative sign. Therefore, in this particular problem, we have got the movement having nature as clockwise. So, therefore, summation MA we get it as a clockwise. Answer is positive over here. And by substituting this value in this particular equation, we can get the answer of x, and x is equal to 9.3 centimeter from point A. This distance is a perpendicular distance from point A. Certain points are to be remembered while solving these problems, and this can be explained shortly or summarized like this. that always determine the angle made by each force with the horizontal to find horizontal and vertical components. You should remember that the horizontal components are to be always calculated as f cos theta and vertical components are to be calculated as f sin theta, provided that theta is the angle made by each force with the horizontal. Use proper convention for finding algebraic sum of horizontal components and vertical components. Then moment of force is to be always taken as product of force and perpendicular distance between line of action of force and point of rotation. Use proper sign convention for determining algebraic sum of moment of all the forces. You have learned some important topics so far, and we hope you had good time learning with us. Browse through our online library for more content on the MSBT website. Thank you. Stay connected. Happy learning.